Okay, Year 12, I'm going to go through the last part of the assessment task 3, which involves calculating binomial distribution correlation combination coefficients. So let's have a look at the question first. So here's assessment task 3. And what it does, so you think that this is pretty easy and you'd be right in a certain regard, because all you're doing is answering these questions. But as part of the assessment, I want you to calculate these. Now, that's why we're doing it via an assignment, because this is the questions in our textbook. How do we get these numbers? To get these numbers, we need to do a combination using Pascal's triangle. So let's have a look at what we're doing. Remember, if I had two things, a plus b to the n, well, the first term would be nc0, a to the n, and b to the n minus, that's going to be an r, a to the n minus r. So that's what each term's going to be. So if I start at the first one, I'm going to get 0, and I'm going to get, that's going to be a to the 0, and that's going to be a to the n. And then the next one along will be nc1. Actually, sorry, that will be a to the n, that'll be b to the 0. And this will be a to the n minus 1, and this will be b to the 1, and the next one will be nc2, and so on, a to the n minus 2, and b to the 2. So if we were doing something like, I don't know, tossing a coin and trying to find out the number of sixes, we could say, oh, I'll let A be the chance of getting a 6 and B be the chance of not getting a 6. Well, we could have, and let's say we now did this for 100, because that's what we're going to be doing. Our first term would be 100 C0, 1 on 6 to the 100, 5 on 6 to the 0. And that'd tell us the probability of getting 100 sixes. How many different ways? And then 100 C1 would be 1 on 6 to the 99 and 5 on 6 to the 1. And that'd tell us the probability of getting 99 sixes. But we're not doing sixes. We're doing heads and tails. So I'm going to let this be the probability of a tail, and this be the probability of a head. So all of a sudden now, these things change. So I get 100 tails, and this is half to the power of 0. And this is 99 tails and 1 head. And the next one would be 98 tails and 2 heads. And so on, all the way down. So you can see that doing that for 100 would be really difficult. That's why we're going to use a spreadsheet. Now, our textbook actually does this really well. Let's have a look at how they do it. So you can see here we get our n. So this is for some probability of 0.3 over 25. So this is something that goes, the possibility of p has a 0.3 chance, and we're doing 25. All right, so 25 of these. And like whatever it is, whatever 25 days at 30% chance of rain. And you could have no days of rain, 1 day of rain, 2 days of rain, 3 days of rain, 4, so on, all the way along. And until you get actually 25 days of rain. And you can go along and do that. So how do we do that? So let's go here and we'll start. So we're going to set up a spreadsheet. I'm going to do this from scratch. I have already done it over here, but I'm going to do it from scratch so you can see. So we're going to open a spreadsheet, any spreadsheet, and in here, let me get rid of that. I wish that wouldn't come up. Can I get rid of that totally? Anyway, so here, this is going to be how many trials. So we're going to do it for 100. By the way, you have to do it for 25, 50, 100, and 1,000. I'm going to do 100 and 1,000 because 1,000 is the largest. And you're going to do it for 25, 50, and 500. You have to do them all, but you watch. Once you see it, it's pretty easy. Once you do one. So back to the spreadsheet. N is 100. This is going to be my NCR. This is going to be my 0.5 to the power of R. And this is my 1 minus 0.5. Now, I know that is 0.5 to the power of N minus R. And then in here, I'm going to have NCR times 0.5 to the power of R times 1 minus 0.5 to the power of N minus R. And that sounds complicated, but when you see what we have to do, it's not that hard. Okay, let's make that a bit bigger. So the first thing, I have to start at 0, remember that, and I have to get 100 of these. So equals that plus 1. We've done this before. Copy that and go all the way down to 102 and paste. There's my 100 trials. Now, on my 100 expansions. NCR. To get this, you go combinations. Try typing equals first. Equals combin, number of objects. So what do we need? Oh, we need 100 C0, that cell. Close that. Now that should be 1, and it is. And then it's got autofill. Yes, I like that. And there you go, 100 for, so these are the numbers going down, all the coefficients in Pascal's triangle. So here, what I want to do is I want to get 0.5. So I'm going to go 0. Try typing equals 0.5 to the power of this. Why did it do that? Sorry, that should be A0, A2, and that's 1, because anything to the power of 0 is 1. I'm going to copy that, and I'm going to paste that all the way down to 100. Because I stuffed it up, I missed the autofill. Now, you're going to think, oh, why are these all 0? Because the chance of getting 100 heads when I toss a coin, or 100 tails, when I toss a coin 100 times, so small, it's going to be close to zero. So that should be and that's just the power of 1. Now this one, this will be the reverse of this. So this equals 1 minus 0.5, which I know is 0.5, to the power of 100 minus that cell. And yes, I want you to autofill. And that will be the reverse all the way down there and ending in 1. So let's go back and have a look at what we've done. So that's 100C0 times a half to the power of 100 times a half to the power of 0. That's 100C1 times a half to the power of 99 times a half to the power of 1. Well, that's your NCR. That's your 0.5 to the power of R. And that's your 1 minus 0.5 to the power of N minus R, or in this case, 100 minus R. And to find the probability, I've just got to multiply those three things together. So I'll go back here, and that's what this last column is. You just go equals your NCR times your probability of that times your probability of the other. And you go autofill. And there you go. And they're all the probabilities. Now, the question asks, and it says here, the exact theoretical probability of obtaining at most 52 heads is calculated using the binomial distribution. That's what we've done. And recorded in the second row. I want you to prove this. So we've got to show that 52% of heads is going to be 0.6914. So here I go. I want the probability of at most 52% of heads and let's just make that so what do I do? Well, I'm just going to add up the sum of E to 101. That should be 1. That's of all the probabilities. But I want, well, that's 0 heads, that's 1 head, that's 2 heads, that's 3 heads, that's 4 heads. I want 50, at least 50, at most 52%. So I've got to add all the ones up to this one here, E54. So instead of going E102, I'm going to go E54. And this number should be the same that's in the table. That's what I want you to prove to me. And there it is, 0.6914, 0.691350. Okay, so we've done that. So now I'm going to do it for 1,000. Well, let's not make it too hard. Let's copy this. Give ourselves a bit of space and paste it. But this time, that is going to be 1,000. This won't change, this formula, but this formula will. This is now 1,000. And so is this one. We only have to change the first 2 rows. That doesn't change. That doesn't change. These 2 do, because I've got to change them to 1,000. And that one to 1,000. And this last one won't change. So I'm just going to make that bigger and then make that bigger. So now all I have to do is copy that and paste it. But before I do that, there's a thing here with Google Sheets. If I go right down to the bottom, it goes, oh, we're only giving you 1,000 rows. I need 1,002. So give me another 1,000 rows, thank you. Go back to the top. Now I'm going to copy these 4 cells, and then I'm going to go there and I have to go all the way down to J 1002. And then I get all my probabilities and it's done. Now, remember, what am I trying to find? I'm trying to find at least, probability of at most, sorry, probability of at most 52%. So again, I'm going to go, well, that's the sum, J2 to 1002. Why am I getting 2? I should only get 1. What's in J2? Is this right? G2, G3, G3, G2. It should add up to 1. Oh, I didn't copy these. I've added up the wrong column. So I've got to copy this. Shift click there, all the way down to 1002 again. They're my probabilities. So I don't need this. I want this to be the sum. And if I go there, and that adds up to 1. But again, I want 52%. Now 52% of 1,000 is 520. But remember, get out of there. I started at 2, so I need 522. And I'm just going to click on that and drive myself up to make sure it stops at 522, at 520. And you can see there, yes, the formula does stop at 522. And now I just have to verify that this number is the same as the one in the table, 0.902026. 0.9026. Now the last bit so that's not, it doesn't say that's part of the question, but that's what I need you to do, to go across and do that. And it's pretty easy. Once you've done the first 2, you'll be able to fly through it. And I probably would have put them in the same order, but that's really easy to do. So if I just select these and cut them, and there's my 1,000. So I'm just going to put these ones in here and I'll paste those in. And there my hundreds there, and these are gone, and I'll just delete these. And now I've got my 1,000 first, and then I've got my 100. And if you want to put more, if you want to put your 500 in, because you've got to do 500 as well. So all you would do is insert some cells there. So insert columns, and let's go, 6 columns to the right. And then you've got enough space to do 500, and then you do 50, then you do 25. So, and that's your big one. So what I'm going to do now is I'm going to do the first bit of this. Oh, come on. All right. And I'm going to do it underneath each, and you can do it underneath or you can do it in the table. I'm going to do it by hand first, and then I'm going to do it on the Excel spreadsheet. So in each case, use a normal approximation for the sample proportion to fill the second row. So it means I've got to fill this row here. Now, how am I going to get an approximation? Well, to get an approximation, you have to use this table, which means you've got to calculate a Z-score. All right? So let's go back and have a look at, well, what the hell is a Z-score? Remember that a Z-score is your score minus the mean over the standard deviation. But let's have a think about the mean. Well, that's easy. That's just P, whatever the probability is. The standard deviation equals the square root of PQ over N. So my standard deviation, or my Z-score, well, what is it? I'm finding X equal to 52%. My mean is P, well, the probability of the head is just 0.5. And my Q, my standard deviation, is 0.5 times 0.5. Now remember, this textbook uses PQ, whereas it should be, you can also use square root of P1 minus P over N. And we're doing 1,000 trials. So my Z-score is 0.52 minus 0.5 over the square root of 0.5 times 0.5 over 1,000. And that will give me my Z-score. So my Z-score, that's the first part. And if I grab my calculator, and you can see I've been doing this, so it's 0.52 minus 0.5 over 1,000. And I get 1.26 491164. And now I go to my my approximation tables, and I'm looking for 1.26. So 1.26, well, here's 1.2, here's 1.26. This is the number I need, and it's 0.8962. So 0.8962. So in this bit here, if you wanted to do it by hand, let's get rid of this. What was it again? 0.8962. 0.8962. But what I'm going to do is I'm going to put that in my table so Z-score equals, now, what was it? 0, so I'm going to go 0.52 minus 0.5 all over the square root of 0, I'm going to have another bracket, 0.5 times 0.5 divided by 1,000, close the bracket. And there you get that. Now, from the table, approximation table, what did we say that came to be? 0.8962 equals 0.8962. There you go. And I'm just going to move all these across. So I'm going to put these here. Hold on. And I'm just going to put this back to sum. And I wanted it to be, what was my sum? 522. All right, so there, that's it. I'm not quite. It wants me to calculate the percentage error. Now, percentage error is easy. Percentage error, when you take a measurement or you're finding the error, you take your score, so your X, minus your error, right, the other score, I'll just put X with the bar, over the original score, I shouldn't be using X with the bar, and I times by 100. So I'm going to go 0.9026 minus 0.8962. So this is my percentage error over the original, the proper one, the exact 0.9026. I'm just going to get rid of this. And then I times by 100. I'll get that up on my calculator. So 0.9026 minus the approximation 0.8962 over 0.9026 times 100. And that's not even 1%. That's 0.7, what is that? 0.709%. It's not even 1% error. Let's do that on our spreadsheet. So percentage error equals this. I'm going to put brackets. Bracket this number minus this number divided by this number times 100. And there you go. There's my percentage error. Now, let's go and do all that for 100. And then you've got to do the others by yourself. So, what do I need to work out? Well, I need a z-score. And the z-score, how do I calculate that again? Oh, you go 0.52. So my z-score is, try typing equals, 0.5, let's put brackets in, 0.52 minus 0.5. That's not right. Where's my z-score again? Yep, that's it. Over the square root divided by square root of 0.5 times 0.5, close that bracket, divided by, now here's a big change, 100. So my z-score is 0.4. So approximation from the table, we've got to find 0.4. So let's go back to the table. 0.4 is here, 0.6554. So 0.6554. Now, I have to calculate the percentage error. Now, what do you reckon will happen? Because that's what they're going to be asking. When I did 1,000 trials, the percentage error wasn't even 1%. Now I'm doing 100 trials. I wonder what the percentage error will be. Well, let's go and find out. Do you think it'll be more or do you think it'll be less? So remember, the percentage error is this number minus this number. Let's put it in parentheses. Divided by this number times 100. 5%. 5% error. And what was the error on 1,000? I'm just going to double check and make sure my formula is right because I don't think I put the parentheses in it. Let's double check. 1,000. Please tell me I put the parentheses in. Yeah, I did. So the difference, that's not even 1% error. Why? Because you've done 1,000 trials. The approximation and the theoretical are starting to match up. Whereas for 100 trials, the percentage error is 5% chance of error. So what do you reckon is going to happen when you do 500? And what do you think is going to happen when you do 50? And what do you think is going to happen when you do 25? All right. So that's what you're trying to do. What I need from you, all right, what I need from you, and you can do it all on the Excel spreadsheet. I can see it all in one go. Do 1,000. I've done it with you for you. Do 100. I've done it with you for you. You then do 500 on your own, 50 on your own, and 25 on your own. And then, and if you do it all on the spreadsheet, you can do those 2 questions on your spreadsheet, and then just make a comment in some box in one of the cells. What happens to the percentage error as the number of trials goes up? What do you think? Don't write me an essay. Please don't write me an essay. Just write me a real simple comment. All right? Good luck with that.